Okay, so in this video we're actually going to talk about calculating vapor pressure reduction of a particular solution given some particular information that's shown up here. Let's just look at the question. It says we have to calculate the vapor pressure of a solution, so this tells us that's what we have to calculate. We have 99.5 grams of sucrose, which is our solute, and 300 mils of water, which is our solvent. We have the vapor pressure of water, pure water, is 23.8 torr, and then we can assume the density is 1 gram per mil. So as with every question like this, the first thing you want to ask yourself is, where do I start? And usually you want to start with some sort of equation that relates something to do with, in this case, vapor pressure. So let's look at the equation that we've seen before, where we can say the vapor pressure of a particular solution is equal to the vapor pressure of that pure solvent, but that also takes into account the solute that's present. Okay, remember this is a colligative property, so the nature of the solute is not important. If there's a bunch of solute there, then the amount of solvent is less, and so that will be reflected in the mole fraction of our solvent. So this is what we're going to start off with. We know this is what we need. This pure solvent vapor pressure we actually have right there, and so you can see the thing that we want to calculate here that our answer is going to hinge on is the mole fraction, in this case, of the solvent. Now mole fraction implies we need the moles of our solvent, but in order to get the mole fraction we need the moles of our solute as well, and that's where these numbers come in. Alright, so let's do it for our solute first. We know we have 99.5 grams of our sucrose, and that's C11H22O11. Okay, and we know that in 1 mole of that C12, oh sorry, that should be 12, just checking you guys are listening, C12H22O11, you know what, that should be 12 as well, balls, sorry about that everybody, that should be 12. Anyway, in 1 mole of that, if we add up all our atomic weights, we get to 342.3 grams of sucrose. And when we do that calculation, what we end up with is an answer of 0.2907 moles of sucrose. And that's good because we need moles of our solute, which is what we've got, but we need moles of our solvent as well. So let's start with the number that we're given, which in this case is 300 mils of H2O. Alright. Now of course mils is no use if we want moles, because we have to go through grams. So how do we go from grams to mils, or from mils to grams in this case? Well, of course we use our density. We know we can say 1 gram per mil gives us our mass, and then we're going to do what we did up here. It's H2O we're talking about here, so we can say, well, in every 1 mole of H2O we have approximately 18.02 grams of H2O, and when we calculate that out, it gives us an answer of 16.65 moles of H2O. Okay, so we have our two answers, or we have our two numbers of moles, I should say. So now we're going to calculate this. We know that mole fraction is the moles of whatever you're looking for divided by the moles of everything. In this case, moles of solvent on top, moles of solvent plus solute on the bottom. So mole fraction, solvent. Moles of our solvent, we said already. No, I'm sorry, I was about to do it for solute. Again, just checking you guys are listening and that I know what I'm doing. Apparently I don't. We have 16.65 moles of H2O on the top, and on the bottom we have the moles of everything, which is again 16.65 moles of our water, which I've said before is our solvent, plus in this case we add in the moles of our solute, 0.2907 moles. In this case it's our C12H22O11, our sucrose. And when we add all those up and divide this by this, these two numbers are going to be very similar because this one's very small. It gives us a mole fraction for our solvent of 0.9828, which really shouldn't be a problem. Again, it shouldn't be a surprise, again, considering these two numbers are so similar. And then all we do is we just take this number and plug it into our formula up here. So once again, we're going to calculate the vapor pressure of our solution. And that's going to be equal to the vapor pressure of our pure solvent, okay, 23.8 torr times 0.9828. Now notice there are no units here, it's just a ratio, moles over moles. So the vapor pressure of our solution has gone down a bit, but not much, again because the number of moles of our solute relative to our water was exceedingly small. So it only goes down by a very small amount to 23.4 torr. Okay. If this number of grams was a lot bigger, then of course our number of moles here would be bigger, and thus the number of moles here would be bigger, which would make our mole fraction of solvent smaller, which would then make the vapor pressure lower. Okay, so you can see it's completely dependent on the amount of your solute that you add in. Okay, there you go.